Hey guys, welcome back to 1.4b. In class, we did explicit functions for arithmetic sequences, and now we're going to learn how to write them for geometric sequences. Remember, geometric sequences are sequences where you're multiplying by the same number each time. Okay, so if you can look, I have, let me write this down, number each time. Okay, I have an example sequence right here. If you could write that down for me. And it looks like, so 3 is our first term, 6 is our second term, 12 is our third term. I'm going to put term number, okay, because the actual term is here. So we're doing the same table, but we're just kind of doing it shorthand, all right? Fourth, fifth, sixth, dot, 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 n, okay? And then here, below n is going to be our function that we create, okay? Our f of n, that didn't come out there, but that's going to be our f of n, right? So we are multiplying by 2 each time. So if we start off, if we have term 1 is 3, how do I get 3 by multiplying by 2? So that's a tricky question because the only way I'm going to get 3 by multiplying is to multiply 3 by 1, right? 3 by 1 is going to give me 3. Now, here's what I want you to try to remember. What exponent, remember exponents are repeated multiplication. Let's put that over here. Exponents are repeated multiplication. So how can I write an exponent that's going to give me a 1 back? And here's what I also want you to remember, and you're going to need to remember this for the rest of your lives in math, is that any number to the 0 power is equal to 1. Okay, so 10 to the 0 power is 1. 125 to the 0 power is 1. Even if I have a variable, I have r to the 0 power, that's still going to be 1. Okay, so if we're multiplying by 2, I'm going to multiply by 2, but I'm going to multiply it by the 1 power. Okay, the 0 power. How could you let me do that? The 0 power. Remember, we're talking about term 1, and it's 2 to the 0 power. So term 2 is 6, and we get that by multiplying 3 times 2 one time, because 3 times 2 is 6. T3 is 12, and we get that by multiplying 3 by what is 12? 3 by 4 is 12. How do I write 4 using base 2? Well, 2 squared is 4. So I'm going to multiply that by 2 squared. Okay, and you guys see the pattern. You can probably just write it like that. But the next one, 3 times what is going to give me 24? That's going to be 8. How do I write that? Well, 2 cubed is 8. 2 times 2 times 2 is 8. So T4 is 24. We get that by taking 3 and multiplying it by 2 cubed. So 3 times 8 is 24. So as you can guess, t to the 5th power, 48 is going to be, and they use base 2 in computers a lot. 3 times what is 48? And that's 16, I think, and 2 to the 4th power is 16. The 6th term, the last one we're going to put here, was 96. And you guessed it, we are just going to do 2 to the 5th power. Okay, 3 times 2 to the 5th power. All right, so what does that look like for any term number, right? So t to the n. So you've got to look at your term number, the numbers I've been circling, And the first one, so for the first term, the exponent I use is 0. For the second term, the exponent I use is 1. For the third term, the exponent is 2. I think you guys can already figure out what is happening. It's going to give us, let's see, f of n, our function of n, is going to be 3 times 2 to the n minus 1, right? 3 times 2 to the n minus 1, where n minus 1 is the predecessor to the term number. Did I spell that predecessor? I may not have spelled that correctly. Okay, 3 is our starting value. And 2 is our common ratio. Remember, it was a common difference. It was a common difference when we're talking about arithmetic sequences, and it's a common ratio now that we're talking about geometric sequences. So the formula is f of n equals your starting value, or f of 1, okay, times r to the n minus 1, right? So our common ratio is represented by r for ratio, and our predecessor at n minus 1 is represented in the numerator, and now that always has to be, if this is our starting value is represented by 1, because that way our starting value is represented by 1, f of 1, because when I put 1 minus 1 here, that's going to be 0, which makes this whole thing, part r to the n minus 1, r to the 0, a 1, and 1 times the starting value is just going to be the starting value. So that is why it looks that way, okay? And then if you want to write down the steps that you did on your own, or we will also do them in class, but don't forget you needed to have written those down for the arithmetic sequences. And oh, it looks like this is going to be a short video. What I can have you do, if you want to stay on, is show you or remind you how to create, oops, I don't have my, I'm going to pause you for just a second, how to create a scatter plot on a calculator using a table. You might want to put these somewhere called calculator notes, because I'll let you use calculator notes on the test. Okay, and here are the calculator notes for creating a scatter plot on your calculator. So let's go ahead and put our numbers into a table. And to get to the table, you do second stat. Okay, and here's our list. So I'm going to hit enter on the list. Oops, that was not what I wanted to do. Second stat, edit. Nope. Just stat, edit. There we go, there's our lists. And I just didn't want to remake this, so I'm going to keep pressing through. So to backtrack, if I clear everything out of here, so we can start again just really quickly. If I clear everything out, we do stat and then edit, which is 1. And then you're at your lists. So let's put in our term number here. So that's 1, right? And then our first term was 3, right? And then 2, 3, 4, 5, 6. And then it was 3, 6, 12, 24, 48, 96. Okay, and you may remember this from last year in class. So we put those in, and now we have to go to second stat plot. okay, which is that y equals button. So, but the second button first and then the y equals, and then see how they're all off, off, off. We want to hit enter on one of them, and the first thing we want to do is hit enter on the on so that it's blinking, the cursor's blinking on the on. And if you look at the scatter plot is already highlighted there. We could have highlighted the line plot, the bar graph, or the histogram, the box plot, but we just want the scatter plot for these numbers, okay? And then we put our numbers into L1 and L2. If you put them into different lists, that's going to be different. And then there's a couple things I want to do. I want to check y equals first and make sure it's clear so I don't get messy graphs and a graph on top of a graph. And then we're going to do zoom. And whenever I use lists or the stat button, I always do zoom stat, which is the 9. Okay, and there's our graph. And I can't remember who was showing us in class. I think it was, oh, you're going to kill me for not remembering your name. But you showed us what it looked like, and that's what it is. It's going to be an exponential relationship. So we will go over that again tomorrow, but that might help show you how you could graph it there. And then you could go, well, I'll save that for another time. I was going to say you could create the equation. We could double check it, but we'll check that next time. So make sure you have these notes. We will be doing real world practice problems in class the next time I see you. So I hope you are safe until then.